All right, so friends, this is the post. You can see this post in the chat. Try and share your knowledge. Okay, what I want basically is to see what all kind of different analytics basically you want to look at. Right, so let me try and see all the comments. Yeah. I'm not able to see the comments. It's not loading here. Let me try and load from here. Yeah, so a lot of people have talked about Docker. People have spoken about Flask, Streamlit, Heroku, Django, right? All these are readily available tools that we have been covering, right? So we have been covering all these different modules. We have covered Flask, we have covered Fast API, we have covered Django. These are the 3 web framework libraries in Python, which will enable us to come up with a UI. And then we also talked about the local deployment, because ultimately the software has to sit on some server. So we try to deploy the server along with the UI capabilities on the local machine. Then we also tried to deploy that in platforms like Heroku, which is a public cloud. It basically serves as a platform as a service. We also have worked on Streamlit, and we also have looked at Docker. But Docker, probably we will be re-looking into it, because that is one of the most important application for us to ensure that the application that we're developing is productionized without any issues. So we'll also talk about the challenges today. And most importantly, we are going to talk about the AWS feature. So we are jumping into cloud platforms, which can be used for various purposes. And here we are trying to look at one of the features from AWS Cloud, which is called as Elastic Beanstalk. What exactly is Beanstalk? How is it different from our regular EC2 instances, right? These are the things that we will be discussing now. So once again, if I have to talk about the entire, let me just pop up my marker. It's loading. Yeah, there you go. So we are talking about different tools which will allow us to deploy machine learning models. Now, Python is the default one. And within the Python, we will be using Flask web development framework. This is one of the popularly used micro framework service. So we will be sticking to that because it's easier, and a lot of readily available templates and code is there. It becomes easy for developers. So this is your code, right? Your machine learning code. It contains the entire trained model, data pre-processing pipeline steps, everything that we need to do while we are developing a machine learning model. Okay. And when we talk about a machine learning model, we need to remember that it has to follow CRISP MLQ methodology. Okay. And why I'm bringing the CRISP MLQ methodology is because we will be also talking about the 5th and 6th stage, which is deployment and maintenance and monitoring, right? So that is another step that we'll have to look at. So as part of the regular work, we load the data, we basically pre-process the data, we try to choose the model, then we try to build the model, do the tuning, choose the best model, and along with the pipeline, along with the data pre-processing steps, we'll also try to train the model, and then save that model. On top of the saved model, we will try and develop a web framework. HTML code can be embedded along with your model. This entire code has to be deployed. How will you deploy? Now, as I mentioned, there are a plethora of different techniques that we can use. Today, we are talking about AWS Beanstalk, and we are also using containerization concept thanks to the Docker implementation. Now, we want to understand what exactly is Docker and how it is right, useful in the deployment part. We did discuss, you might want to refer to the previous previous videos of this channel, of this particular series, deployment series, so that right, you understand different aspects of various other tools that we have worked on. So you can see here, the end-to-end pipeline basically comes from source. Your data comes from source. It all goes into a specific repository, data repository, we call it as database. That data will be pre-processed. Then model development happens. Best model will be chosen. And then we try to use Flask application on top of that model. This is what we've been discussing. Now, what you do, let's say you want to deploy this application. What will you do? Will you use your local machine? Or are you going to give your server to client? Absolutely not. So the code that the team has developed, the application that has been developed, has to be shared with the client. Because the code that is developed can be residing in any of the system. Now, forget about deployment, even before the deployment. Let's say you are developing the application model, and you are saying that, hey, this model that we have built is performing at, let's say, 92% accuracy, or RMSE is 0.8, you can say. Okay, 92% accurate. Assume. Now, your client would definitely want to verify this. This is your claim, right? So you're using one server. This is for your development. The code that you have developed will contain Python libraries, data sets, the right, OS versions, library files, OS library files. Lot of dependencies would be there. We generally come up with a virtual environment to ensure that the model is perfectly working in that particular environment. Now, when you give the code, you only give the code to your client. So here at the client, there will be testing team. Forget about client. You might have your own testing team. The expectation is that the model that team has developed should try and give almost similar performance for the consistency purpose, acceptancy purpose. But this is a different server. This is a different server, right? Physically, these systems are completely different. Now, when physically these computers are different, the OS levels might be different. The OS versions, the various dependency softwares might be different. Python version could be different. Various packages versions could be different. So a lot of mismatch might be there. Now, because of this mismatch, on the test environment, your code might not work. Right? So this is where we get to this particular problem. Right? We have seen this slide already. It worked on my machine. This is the standard answer that we give, isn't it? Hey, it's working perfectly fine in my system. But for the testing team, it doesn't work. It throws random errors. So how do you avoid this scenario and also ensure that this is wasting a lot of time, isn't it? Troubleshooting the issues and all that. So prerequisite setup will be a lot. And what if hardware configurations are different? Servers will also have hardware differences, right? Configuration differences. So if that is the case, then irrespective of whatever you update from a software perspective, the system would not work. The application would not work on that particular system because of the lack of resources. Right? So these are the challenges that we need to address. And this is where Docker comes into the picture. Docker is basically a software. You can say it's a software. And it basically allows us to create a closed template of your application, right? You can basically call it as a container, but what I would say is like a template. You save whatever you have done, and this template is from application level. All the libraries that are required will automatically be updated in that particular application. So it also records what are the prerequisites. What happens this way is when you are trying to give the developed code as a container to different systems, different people, different team members, they will not have any dependency issues. The template as is will work. All we need to have is a Docker software installed in those systems. That's all. You forget about all the OS dependencies and all that. Now, a lot of people probably might be familiar with containerization and virtualization. Virtualization is probably was very, very popular a few years ago, which basically allows us to split the hardware capability. Okay, virtualization versus containerization. So when you talk about virtualization, it takes the capacity of the server. Let's say I have 22 I core. This is a standard example that I generally give, right? I22 core. And it has, let's say, 64 GB memory. And probably it has 2 petabytes of storage. This is a server, by the way, okay? High configuration. Now, in the organization, when your teams are working, you don't want to give such a powerful machine to your team members who are probably working on different projects. There will be a lot of ambiguities generated, overlapping of functionalities, cross-functionality issues, all those things come up, access issues. So you probably have one option, that is kind of give the shared access to the server's resources. You may say that, hey, why not I purchase computers, right? Different teams have different requirements, so why not we purchase servers? But you cannot do that, right? You cannot keep purchasing servers, all right? So that's not a good idea. It's unnecessarily adding the cost to the company. And unnecessary usage, right? I mean, you're not utilizing the server capacity that you have procured. This is where virtualization comes into the picture. So what we do is we create a virtual machine. We call it as virtual machine. Physically, you'll have a single system, single server, but virtually, you're going to create multiple machines on that physical machine. Now, what you do is you allocate some of these resources to virtual machine. Similarly, you'll have virtual machine 2, so on and so forth. Now, what happens is this becomes an independent computer virtually. It is not physically present, but it becomes a separate computer. Now, what happens in this way is multiple team members can utilize the capacity of the same server, right? And they will be able to manage, the admins will be able to manage the usage of those virtual machines. And once the work is done, they can probably, right, dissolve it, decompose it, and then put it back into the pool. Dissolve it, right? So that is basically the approach. But the problem is virtual machine is very heavy, right? Entire computer is created. And it's like separate machine. You'll have to have operating systems. You have to have all the machine, all the dependencies installed, right? Everything has to be reinstalled. It's just like a separate computer, which becomes, again, tiresome and right, repetitive work. So this is where containerization concept came up. A container is a standard unit of software. It is not a virtual machine. It's not physically trying to separate your system, but it is a software which tries to package all the code and the dependencies, right? And it can be used. I mean, this is like a template, as I mentioned. These templates become independent, but all of them will be using the same hardware, same operating system. You don't need separate operating system, separate dependencies and all that. Even if you have dependencies, you can have all those dependencies within the container. So you can have n number of containers irrespective of the capacity of the hardware, and all the containers basically use the capacity of the single server, right? So it is a software that we are trying to use so that we create a, you can say it's like a folder, it's like a software that we are trying to install on a computer, but single computer, independently each of that is going to work. So containerization is basically called as a OS level virtualization, right? Operating system level virtualization. So it's not physically separating the hardware. That is important point that we need to remember. This way, what I can do is I can, as a developer, create a template. We call it as a container or an image. We call it as a Docker image. Nothing but your entire software. Everything, right, packaged together. Now, this package, the image, can be given to n number of people without any issues, irrespective of where it is getting updated or where it is getting installed. Now, this way, what happens is all the dependencies that we basically get while your deployment can be automatically addressed, right? Majority of the issues are handled by containerization concept, and hence we have to look at the Docker containerization. So just a quick walkthrough. Docker image is a unit of package which contains everything that is required to run the application. So your ML code, your Flask code, the libraries, if you have any OS dependencies, those OS dependencies will be there. Right? All the required dependencies along with the code will be there. Now, what we do is we define that as an image. It's like a saved copy. We build the image. This is like a offline file. When you want to use it, we need to push a container on top of this image. So we'll have to start container. So it takes image and allocates the environment capacities, your execution environment capabilities, so that that software can be installed. Right? And all these images are generally stored in a centralized hub. There are many hubs. All the private cloud platforms also have their own respective hubs where all the developed code generally resides. And the public repository is Docker Hub. Okay, so we basically dump everything here in that. And when you want to use, you just give the Docker Hub name. And once you install the Docker, it internally gets connected to the Docker Hub, the centralized repository. And when you want to get the respective image, irrespective of where you are running it, you just build the image, right, on your local machine and then push it to the container. Container is nothing but, as I said, a runtime execution of the application. So it's just a dump. Images are nothing but just a dump. Okay. And this is your container, which is runtime instance. And you can have many images. We also have versions of those images, right? All those things, code repository concepts are maintained by Docker automatically. So everything is automatically managed. You don't have to really worry about all that. So we use Docker desktop API, or we can also use the command line interface, whichever you're comfortable with. And then there are a series of commands that you do, which allow us to build. So you're building the image on your local machine. Okay, you build. This image can be shipped into the centralized Docker Hub. Right? You can register that. And then you can use that centralized repository to pull the container from the image and then define the container for your application. This is the 3 steps that we generally have. Right? Very simple. I'll show you how to do that also. And these are a bunch of queries. You can also see this cheat sheet readily available on the Docker platform itself. I've already shown this in the previous presentation. Go to the docker.com and you'll be able to see all these cheat sheets. Build, share, and run. These are the three important right, stages of your Docker image creation and container creation. Now, let's say we have created a Docker, and let me show you. Docker image creation is very, very, very simple. So I will talk about this. Yeah, we will be making sure that you get the access to this document also. We'll share the link. These are the basic steps of your Docker image creation. Okay, this document has the installation steps of Docker. Okay, system requirements, how do you install the Docker on Windows, and then you have right, the screenshots for all these steps. And it also talks about how you can take the dependencies, install them, etc. Now, once we install this, I'm not walking you through with the entire installation step. I expect you to do that. This is what you will see. This is the Docker desktop. I have flashed everything so that you understand how empty Docker desktop looks like. You can sign in, you can register yourself in the Docker hub. So I'm not doing that. And these are the images. So you can see I don't have any image. Okay, I will show you the Docker hub image. Docker hub. This is the Docker hub. Okay, and it is explore. So these are all different images that are readily available, right? Hundreds and thousands of Docker images are there. Okay. So I'll show you how we can try and use the Docker here. All we are going to say is open a command prompt. I'm specifically navigating to this location because my code for deployment is in this folder. You can run the Docker image from any location. I'll probably say CMD. I'll say Docker image. So you can see there's nothing because I don't have any Dockers. So you can just type Docker and you can see all the help is available. Right? All the options for your Docker command are given. You can go through it and experiment. It's okay. It's not going to harm anyway. You just experiment this. Now I will show you how Linux Docker can be installed. Okay, so all we will do is, I think I have deleted this. Let me. I'll go back to this. Yeah, this is the command. I think I have removed that. Fine. So what I'll do is I'll try to build Ubuntu. Okay, and I will try to run this. Yeah. I'll just copy this. Ubuntu is an image which is by default available. So you can also see that here. You can search for Ubuntu. See, Ubuntu official image is available. That means you will be able to create your Linux operating system within seconds. Right? All you have to do is pull the Docker image from the Docker hub. This is pull command will allow you to get the Docker image. Yeah, we'll just wait for this to done. Yeah, you can see it is full complete. So new version is downloaded. You can say Docker images. You can see that this Docker images installed. Okay. You can also see in the desktop your Ubuntu is available and it is running. You can click on run. This is an image. Once the container is up and running, you'll be able to see the environment which is up and running. Okay. Now what I'll do is I'll try to work with the code that we have been using for our discussion. This code is basically talking about fuel efficiency. And what we are doing here is trying to create Okay, let me just try and drag this into Spider so that I can also try. Yeah. So what we're doing is in our ML code, we have basically implemented the steps where I'm doing the data pre-processing. This is for one-hot encoding. And this is the pickle file, which is basically used for saving the model. Again, just to keep the model and the data pipeline different, I've used joblib and pickle, but you can use both, any one of them. Right? That's your choice. Then I'm writing a function which will try and render, navigate to this page, and there the action begins in the HTML right, index.html page, where we will try and read the CSV file. Right, it basically requests for the file, and we'll pass the file, and it loads the file. This data is getting converted to NumPy, and then we are using this transformer to convert the data into one-hot encoded form, and then using this model, MLR model, to predict the output. This output is shared in Y2, it's saved in Y2, and I'm creating a new column in the data object that we have created. And all I'm doing is I'm trying to present it to the end user. Now this, in a local machine, you can simply do. So go to the location and say your steps, Python space app.py. But remember, we are trying to create an image which can be passed to the AWS Cloud. So for that, again, I will take these steps. I'm navigating to that location. I think I'm already there in that location. Yeah, I'm already there in that location. And here we need to have a file called Docker file. Okay, so I will also talk about that file. So the prerequisites for deploying the Docker container on AWS Cloud is basically the code itself. And then we also have to have the respective softwares. This is the Docker file. This is a generic file. So we have a Docker file. Okay, this is the mandatory file that you can see here. Docker file. This Docker file will contain all the dependencies that are required. It basically tells where those dependencies can be captured from, what is the port number which this application is getting exposed to, right? So that your external world can access that. And it also says, hey, copy these files which are required. And in order to install all the things that are there in requirements.txt, you need pip3 in that environment that you're trying to create, right? Virtual environment that we're creating, container we are creating. So first we are saying pip3 install. Okay, and then we are saying install all the required softwares that are mentioned in this particular file. Again, I'll open this in a notepad. So these are all different softwares you can add, you can remove, which are required, which are not required, right? So I just dumped everything as in how I face some of the issue. I keep updating this, but if you want to keep the software light, you only pass the packages which are required. Okay. Now what happens is in that container, all these packages gets installed. Okay. We're not basically running the entire production-based instance. So I'm just basically using small application here. And we're basically trying to copy this file from the local machine to the container folder. That container folder has the folder called Flask_Docker. Under the root directory, it is getting created. By default, Docker creates Linux machines. Okay, and that's the root directory. Inside that, we are trying to move the files that we have here so that your environment is set up. And then we are copying everything. And at the command prompt, we are running this function. Host 0000 basically is ensuring that the endpoint that we are defining in the Docker is publicly accessible from any domain, any location. If you want to put a restriction, you can put the IPv addresses, your domain addresses can be used. The IP addresses can be restricted. So this is the Docker file. Again, this is like more of a standard file that you have. So I'll come here, and the commands that I'm going to run are this. This is the command I'll be running. Yeah, this one. Let me just copy this. And I'm pasting it. So you can see what is happening is the entire content that is there in that folder is getting updated. Okay. It's basically pushed. Working directory is created, copied, and everything has been created. And this is our file. So if I say Docker images now, you will see the two files, right? One of the Docker image that we just now created is Ubuntu, and this is the fuel efficiency function, the image name that we are giving for our Docker. So we are building fuel efficiency image. All right, so this is to create an image. Okay, and when you want to work with this particular image, you would probably need to run it. So I would say run Docker run -p. The port number is 5000, and the image name is fuel efficiency. If I run that, it gives the entire code a hit, and then we are trying to bring up the URL. Now this URL can be used here, and there's the code, right? So whatever we have built in our local machine is now there on the Docker image. You can also use this Docker image. All you need to have is the Docker installation done. And when I pass new data, I can get the results. Right? So this is how the functionality of ML model can be used in the Docker. But remember, when we talk about installation, okay, the most important thing is challenges. What are the challenges with respect to your deployment? This is a very, very popular image, which is given by Google, and it's an illustration to tell the practical challenges that we will have with respect to deploying an application. All right. The answer to all this is a very simple statement. Your data drifts. Over time, business evolves, and because of that, your data changes. It could be with respect to schemas, it could be with respect to one-or-two features, additional features, internal features could be there, external features could be there. New processes can be probably brought down. The scalability of the application because of the usage. It could be scale up requirement could be there, or scale down requirement could be there, right? And whatever the data that we are working with is basically a sample data, right? And yeah, even before drift, the test data might be different. The distribution of the data might be different, isn't it? So these are all various different challenges that you will have when you're trying to deploy a machine learning model, right? And hence, we try to use the Elastic Beanstalk. But what is this Elastic Beanstalk? Now you might say, I will be deploying it on cloud. There are cloud platforms like unlimited resources are there. So why not we use EC2 instance? Isn't it? You can absolutely do that, EC2 instances. But the problem is, for EC2 instances, you will have to manually define the resources that you are going to request for. What memory, what server calculations, what kind of data volume will be there, network bandwidth could be there. So distributed or non-distributed environment is required. So a lot of these checks have to be done, and you would have to manage manually. Now that's not easy. It's not at all easy. Because as I mentioned, there are many, many challenges that come into the picture when you try to practically productionize the software. So this is where the most ideal approach in AWS Cloud is Beanstalk. We also call it as Elastic Beanstalk because it is automatically getting adjusted, scaled up or scaled down. The Elastic Beanstalk will enable us to automatically manage all the resources that are required to run your application. You don't have to manually deploy any servers. Everything is automatically taken care of. And this is the best option that you can think of when you're trying to deploy your machine learning model at a production level, where you don't want to manage your resources. Right? This way, automatic scaling will happen. It could be load balancing, it could be different versions, securities, whatnot. And all those things are automatically managed. But of course, remember the cost is something that you have to look at, because it is again a platform as a service like your Heroku. Heroku also is a public platform. It gives you limited access to the resources, but if you want to have a production level deployment, Heroku license is also something which is required. It's also a platform, right? Same way, Beanstalk is an automatic deployment platform which is given from AWS Cloud. So you don't have to worry about the infrastructure that basically is required to run your applications even after some time. Right? And you can simply define this as a logical collection of all the AWS components that are required to successfully configure your application. Right? And it automatically handles all the requirements: capacity provisioning, load balancing, scaling up, scaling down. It also has monitoring, inbuilt monitoring. It has security features as well. Right? And it allows you to do different types of deployment as well. This is the architecture. The blue circle that you're seeing is basically the environment that you have. Right? So when you try and use Beanstalk, right, Elastic Beanstalk, you will have a web server, and of course, you'll also have a queue server. Web server is basically containing these options. It also has load balancer in it. Right? And it provisions all the resources that are required. Right? And as I mentioned, auto scaling group, it can also pull your EC2 instances as well. It automatically does that. And when we talk about environments, there are two types of environments, right? So the deployment can happen in any of these. One is auto scaling environment. Of course, the costing will be very high here. And the other one is dedicated single instance environment. And when we talk about various components, these are the terminologies that are very popular. I mean, these are the terminologies that you need to look at when you talk about AWS Beanstalk. So application, this is nothing but your components, right? It's the entire end result, you can say. A logical collection of Elastic Beanstalk components, right? All the components that are required. That gives you the end result application. The versioning is also maintained, right? In the monitoring aspect of Beanstalk feature, it also ensures that versioning is also maintained. So we have application version as well. It is nothing but a labeled repetition, iteration of the deployment code. If you change something, right, any small change that you can want to make, then that change can also be automatically implemented on your end application, and the versioning is automatically maintained. And you can have many versions, and each of that can be run individually, independently. It's not like you're upgrading one version to the next version. These are disjoint services. This old version can be working on. You can also take up the new version, right? Both can be done. The environment is basically the collection of resources. Application runs on these resources, right? And each environment will have only one application. a set of resources in AWS all together will give you one functionality, one ML model functionality. Right? That's the environment. And environment here basically talks about two types of applications, as I mentioned. And these, right, it basically tries to request serve HTTP requests, and that's called as web server environment. The other one is the simple Amazon queuing service. Right? This is more like an environment which runs in the backend when you have distributed environment and all that. So these are the two different tiers, environment tiers that we have, instances that we have. So depending on what you're trying to achieve, you'll be choosing those different environments, either web server environment or worker environment. Then environment configuration is all the configuration details, which resource is consumed at what level, what are the various parameters, and all these things are there. Then the saved configurations, these are where nothing but your versions, right? One template. So when you try to make some changes, the changed value becomes another version. And platform is nothing but your OS, you can say, right? Operating system and various dependencies that you require. So those are your platforms. And Beanstalk has different images, different platforms. You can choose any of those images. So these are some of the components of your Apache Elastic Beanstalk. And I've shown how to run the deployment of a Docker image. So this image that I have is installed on a local machine, right? I mean, it's there in the Docker Hub. Now, from the Docker Hub, I would be trying and running that image on Beanstalk environment, right? So these are the basically these steps. And if I go to the steps here, so the first step is you try to go to the official documentation of AWS Elastic Beanstalk. So let me share that. You can also directly search for it. And this one is basically giving you the instructions on how you install the Elastic Beanstalk from a command line interface on your Windows instance as well. This is with respect to Windows. If you basically stick with pip and all these, right? So you can basically install it on any of these operating systems. So I'll go to Windows directly. I need minimum 3.7 Python and of course pip installed in it. Right? And if it is not there, ensure that it is installed. And then you can check Python version. I'll show you. Okay, it's not there. Okay, I'll just come out of this image. I'll try and okay, I'll just close that and I'll open another command prompt. I'll navigate to the folder where I have this files. So this is the location where all my deployed files are there. Okay, and this is our actual Python code, and this is your Flask application. This is the machine learning model, saved model, and this is the data pipeline. Docker file and requirements file. These are required for creating the image from this Docker software. Right? So using Docker Hub, we are trying to push this image. Let's say Docker images. Yep, it's already there. It's there. So I'll be using this. So for the installation, once the installation is completed using these steps, right? All these steps have to be followed. Right, your environment variables has to be set with respect to the right softwares that is installed. EB basically is getting installed. Elastic base, your Beanstalk is a command line interface fetch. So we will talk about EB underscore EB. I will just go to that location first. Okay, I'll try to say CD. Okay, it's already there, right? Yeah, so and I'll be saying EB -- version. Yeah, so it's basically installed. For me, it's already installed. Next is you need to try and initialize your Elastic Beanstalk. So I'll say EB init. Okay, it's going to take a while, but before you actually go do all this, you need to have your Elastic like Beanstalk application ready. So you'll have to create the service. You need to assign the user for the particular service, and then you need to try and I'll show you. Yeah, so you'll have to log into your AWS console as user, create a user ID, assign that user ID specifically with the access with respect to your Beanstalk, grant full admin level access, and then you basically come to this setup, right? And after the setup, you basically come to the EB init, and post that the remaining steps will be there. Okay, so let us see if the EB init is completed. It says application fuel efficiency has been created. Cannot set up code commit because there is no source control setup. Continuing with initialization. Do you want to set up SSH for your instance? I don't have a certificate, right? Secured connect certificate. So I will say no. SSH certificate is not there. So I'll say no. Okay. So that's all. This application is getting created now. Right? Next comes, I will again have to say EB1, EB init. Why is it automatically? Yeah, now it is coming. So we'll have to do it second time. Okay. Now here it will ask for a key and value pair. Okay, you can probably say new key pair, or you can just say what that is available. I will say 18. Okay, these key and value pairs can be created from your AWS key store. I already have this. Of course, it doesn't work. I'll try to show you. Yeah, this is my user, and the passphrase is this. All right. That I'm basically saying not required. So this application is set up. Next step, right? It basically, if it is asking for the application name and all that, it has to go through all these things. You can create a new application name. Okay, and what we basically say is this thing. It should actually prompt for the region. By default, in our case, it is instance 3, and then it will ask for your the application name. You have to say create new application, because I've already done this some time back. It is basically asking, it's not asking anything for me. That's strange. It should actually ask me. Fine. All right. So next is EB create. So once the application is created, the next step is EB space create. And yeah, the default name, yes, I want to keep that as is. DNS also, I want to keep that as is. And this is an application that I want to run. It is not a classic model, or it is not a network. It is an application. So by default, it is 2. You can also type it or say just enter it. And would you like to enable spot fleet requests for this environment? You can say no. Okay, you can simply say no. Okay, it will ask all this, and then once it is done, it installs. Okay, let me just execute it and then wait for it because it takes a little while to show you the UI. Okay, it's creating the application. It is just uploading the Docker file. And if I go to my AWS, this is my AWS console. I've already logged in. I'm going into the Elastic Beanstalk, and here you can see this is pending. It is now starting up, right? And once it is okay, this is the URL, and you'll be able to access the URL just like how you have accessed in the local machine. If you want to have database connectivity, you can also configure your Beanstalk, right? EB, that is Elastic Beanstalk, to connect with different databases. Security aspects can be set. Version can be maintained. These are nothing but versionings, right? So each of this has a unique ID also, running versions. So everything is in the UI. You can simply see here. These are the applications. And from this application, these are the running environments. It's still getting updated. So you just have to wait. And once it is done, you will get the UI. But as I said, it is connecting over non-secured line, HTTP protocol. If you have license certificate, then you can establish the connection using that certificate. As handshake can happen, and you'll have HTTPS configured. So this is basically how your Beanstalk works. So just to repeat, it basically has very simple steps. It starts with Docker image. And if the Docker image is locally working, right, you anyways deploy it. And if it is locally working, then you can take that Docker image and place it on Elastic Beanstalk. And Elastic Beanstalk is an automatic tool which will manage all the resources that are required for your application to run. And right, we basically have to install it, EB version, EB init, initialize your application. You might want to also safeguard your keys if you have. Then give all these different options, and then it will basically try and ask you the application name if you have a new code, and then right, and create. This would basically create your application. That's all. And at the end, you will get this URL like this, and you can basically take that URL and launch that URL for doing the prediction. So this is about the end-to-end application deployment, ML application deployment with the Docker and with AWS Beanstalk. Now you have to be very careful with respect to the billing. So just a word of caution, you probably want to assign budgets upfront for your users. Under the IAM module in AWS, you will have all these features, right? It's a self-explanatory. You can go into that, take an application user or take a service and say, hey, this service, I want to give only so much budget. And if it's extending, then automatically the service will halt. So this way, you don't have to worry about the unknown billing, right? You can also set overall budget for the entire work that you're doing. You may not know what services are basically being called in the backend because it is an automatic service. So you might want to set up the overall budget for this particular project. And that way, you'll be able to also control the billing of your application. Yeah, so this is done. This is the URL, HTTP:/, and you can also see here. I'll just refresh. And this is your environment, fuel efficiency. I'll just click here, open it a new window. You can see this is the URL, right? And then you'll say, upload your local file that you want to basically pass as an input. And if you say submit, you'll get the result, right? But the good thing is it can be very simply uploaded. The same steps can be applied for your production environment as well. So that's the advantage that you'll get with respect to the Beanstalk, friends. And if you want to terminate this, just to ensure that you don't bill unnecessarily, you can say select and terminate. Okay, you can basically get the link, the name of the application, say terminate. Right, I'll basically go to the environments. I'll also try to stop this as well, because it's right. I don't want the application to give me a big bill. Isn't it? So demo is done. You're also supposed to learn how to terminate these applications. So I'm stopping or terminating this image from the Beanstalk, right? And you can basically try and go to the applications, and here, if it is already shut down, yeah, you can say delete application. That's all. So this application will get released. All the resources get released. That's all. We'll just wait for a couple of minutes. That's already terminated. I'll also delete this.